Okay, so today we're going to look at the next topic that involves calculations. So on Monday we looked at how to calculate concentration using C equals N over V. Now we're going to look at what to do with dilutions. So first of all, we need to talk about what a dilution is, and then we'll see how to use a formula to do some calculations. So sometimes we need to make a solution of a specific concentration by adding water to a solution with a known concentration. We call the solution with the known concentration the stock solution. Okay, so basically the idea here is we have a solution that's already prepared and we know what its concentration is. So we call that the stock solution. So let's say maybe it's like 0.5 moles per liter. But we need to prepare a second solution that's less concentrated than that. So what you can do to make something less concentrated is you can add water, and when you add water, you dilute the solution. You make it less concentrated. So you've probably heard the word dilute before, and you probably have some sense of what that word means. So adding water to a stock solution to prepare a solution with a different concentration is called dilution. We call it this because the new solution will have a lower concentration or a more dilute concentration of solute. So we can actually do some calculations involving dilutions, and the equation is fairly simple. We take the concentration and volume of one solution and set it equal to the concentration and volume of a second solution. So let's just talk about which solution is which here. So C1 is the initial or starting concentration, and V1 is the volume of that starting solution. C2 is the final concentration of the dilute solution, so once the water has been added, and V2 is the final volume of the dilute solution. Okay, so this is like your stock solution, and this is once it's been diluted. Okay, so let's just try some problems so you can see how this all works. The steps are written here, but it's easier to understand the steps by actually doing it. It's basically just that you'll get 3 of the 4 variables and you're going to solve for the 4th. Okay, so first problem is that water is added to 200 milliliters of 2.4 mole per liter cleaning solution until the final volume is 1 liter. Find the concentration of the final diluted solution. Okay, so a few things before we can start. Because our concentration is in moles per liter, our volume has to be in liters. So the 200 milliliters, you can convert it in your head. I'll just do this one by writing it all out. So we divide by 1,000, and that will give us 0.2 liters. Okay, here's our formula. So we might want to make a list and figure out what do we have in the question. Okay, so water is added to 200 milliliters of 2.4 mole per liter cleaning solution. Okay, so that means our initial concentration is 2.4. Okay, I know that's the initial because water is being added to it, right? So the C2, V2 are after the water's been added. Okay, so the initial volume is, 0.2 liters, and it is added until you get a final volume of 1 liter. Okay, what is the concentration of the diluted solution? So just think about this. Okay, we're adding water until we get a volume of 1 liter. So we're adding 800 milliliters of water here. So we want to see that this concentration, 2.4, which is what we started with, the final concentration should be lower than that, right? Because we're adding water to make it more dilute. So let's just plug in what we have. 2.4 moles per liter times 0.2 liters equals C2 times 1. So I'm going to just divide both sides by 1. And when I do that, I'm going to multiply, and really dividing by 1 won't do anything. So my C2 would equal 0.48 moles per liter. Okay, so now if I compare that, I can see that the diluted solution is much less concentrated than the stock solution. So that's good. That's what should happen. Your other approach could be to rearrange first. So I'll just show you that over here just so that you know if you like. So if we're solving for C2, we want to isolate C2. So I could divide both sides by V2, and my formula would become C2 equals C1 V1 over V2. So really, it all ends up the same, right? That's exactly what I did here. It's just here I did it with numbers, and here I did it with letters. Okay, let's try another one. A Chem 30S student is instructed to dilute a solution of hydrochloric acid that has a concentration of 11.6 moles per liter to make 3.5 liters of 2 mole per liter hydrochloric acid. What volume of HCl solution should the student measure out to add water to? Okay, so we've got everything in the correct units. Let's just identify what we're dealing with. Okay, so you're starting with a very concentrated acid, okay, which is 11.6 moles per liter. And you're wanting to make, so you're diluting it to make 3.5 liters, and you want the concentration to be 2 moles per liter. Okay, so this is you would never be asked to actually dilute such a strong acid because, or like such a concentrated acid, because that would be quite dangerous, but you might be in a situation like this where you have to prepare a solution and you need to know how much of that solution to measure out to begin with. Okay, so we're looking for the initial volume that we would need of the concentrated acid and going from there. Okay, so let's try this. Okay, I'm solving for V1. So I could rearrange this to start with to look like this. You're always basically dividing by the one that's partnered up with the one you're trying to solve for. So C2 is 2 moles per liter, V2 is 3.5 liters, and C1 is 11.6. Okay, so when we calculate that out, we would get 0.6 liters. Okay, so that means you need to measure out 0.6 liters or 600 milliliters of the concentrated acid, and then you're adding water until you get 3.5 liters. So you'd actually be adding 2.9 liters of water to dilute it from this concentration to this one. Okay, another one. 1 liter bottle of acetic acid, which is the acid that's found in vinegar, is labeled with a concentration of 17.4 moles per liter. A student dilutes this entire bottle of acetic acid with enough water to prepare a 3 mole per liter solution of acetic acid. What is the volume of the diluted solution, and how much water must be added to dilute the acetic acid to this concentration? So we actually have 2 questions to answer here. Okay, so you always want to pay attention when it says how much water must be added, okay, because then you have to do an additional step once you've done your calculation. So let's just take this one step at a time here. Whoops. Okay, so a 1 liter bottle of acetic acid. So we've got 1 liter is labeled with a concentration of 17.4 moles per liter. A student dilutes this entire bottle with enough to prepare a 3 mole per liter solution. Okay, so we're going to solve for V2, and that will tell us the volume of the diluted solution, and then we'll deal with the second question. So if we're solving for V2, we could write this as V2 equals C1 V1 divided by C2. Okay, so 17.4 moles per liter times 1 liter divided by 3 moles per liter. Getting quite messy here. Okay, so when I do that, what you get is 5.8 liters. Okay, another thing to pay attention to, your C2 should always be less than your C1. Your V2 should always be more than your V1 because you're adding water, so you should have more volume in the end, which it is. Okay, so your final volume of that solution is 5.8 liters. But we want to also know how much water is added. Okay, so we know the final volume and we know the initial volume. So if you subtract those two, you can find out how much water was added. So 5.8 liters minus 1 liter equals 4.8 liters of water must be added. All right. So let's try one last question, and then you can try a few on your own on the assignment. So the final concentration of a diluted solution of sodium chloride is 0.75 moles per liter. So I'm just going to do that. I know that's my final concentration. If the initial volume is 350 milliliters and the initial concentration is 1.35 moles per liter, how much water is added? So here's another time where we're going to have to do that additional step. So I'm solving for V2. So V2 is equal to C1 V1 over C2. Okay, so let's plug in what I've got. V1, instead of 350 milliliters, it would be 0.35 liters. And C2, 0.75 moles per liter. Okay, so when I calculate all of this, I get 0.63 liters. But what that only tells me is what the final volume is. I want to know how much water is added. So I take the final volume and I subtract the initial volume. And that is 0.28 liters or 280 milliliters. 0.28 liters of water is added. Okay, so what else could you be asked about that? What is the mass of sodium chloride in the solution? Okay, well, mass means grams. So everything up here has been in moles per liter. So what we can do is we can use our formula, C equals N over V. We know concentration and we know volume. Now, the important part here is the amount of sodium chloride does not change. Okay, so however much sodium chloride is in that solution stays the same throughout because all you're doing is adding water. So to do this next calculation, you can either use C1 and V1 or C2 and V2, as long as you keep them in their matching pairs. So let's do, I'm just going to say option 1, use C1 and V1. Okay, so I'm solving for N, number of moles, and then I'm going to convert that number of moles to grams. So let's just rearrange this. N equals C times V. So concentration C1 is 1.35 mole per liter, and V1 was 0.35. So when I multiply, I get 0.4725 moles. I'm keeping lots of decimals here just so that, because this isn't going to be my final answer, I'm looking for an answer in grams. So I'm going to take that 0.4725 moles of NaCl, and I'm going to convert to grams. The molar mass of sodium chloride is 58.44. That's just sodium's mass plus chlorine's mass. And that works out to 27.61 grams. So that's telling me there's 27.61 grams of sodium chloride dissolved in that solution. Now, just to show you that you can also get to this answer using C2 and V2, I'm just going to quickly show that. Option 2, use C2 and V2. Really doesn't matter, right? Because you're not changing the amount of solute, you're only changing the amount of water. So as long as you keep them paired properly, it should all be good. So C2 was the 0.75 moles per liter. V2 is the 0.63 liters that we calculated. And when you multiply those two, you also get 0.4725 moles. So just showing you arrive at the same number of moles, which you would then convert to grams in the same way. So you guys can work on the same worksheet as last time, but the part 2 section. So it's concentration, dilution, and mixing worksheet number 1, part 2, and those should all be dilution questions.